Today we're going to look at how to calculate the molar mass and percent composition of a compound. And this is something that we've done earlier in the year, determining the molar masses of individual elements. Now we're going to add those molar masses together to determine what the molar mass of a compound is. So you're going to need your periodic table and a calculator, because if you will remember, if we overlay a periodic table here, this number under the bottom of each element is the molar mass, or the atomic mass of that element. And each element has its very own atomic mass, unique atomic mass. So what we're going to do is we're going to add up those masses of each individual element to determine the molar mass of a compound. So make sure you have this worksheet out. And we're going to move down here to the bottom. We're going to kind of skip the simple ones on the top. And we're going to look at these compounds. We're going to look at sodium nitrate first. And in order to write this out, I'm going to switch papers. I'm going to write them out on this sheet here, so we have a little space, a little workspace. So there's the equation for sodium nitrate, NaNO3. What we want to do is we want to determine how many of each atom we have and multiply that by the molar mass, and then add all those together. So we start out here with 3 oxygen atoms, because of that 3 subscript right there. So we have 3 oxygen atoms, and looking on our periodic table, we can see that each oxygen atom has a molar mass of 16.00 grams per mole. Then we have nitrogen. We have 1 nitrogen. Each nitrogen has a molar mass of 14.00. And we have 1 sodium. Each sodium has a molar mass of 22.99. And again, these numbers are taken just off the periodic table. Make sure we're rounding to the nearest hundredth. So our total amount of oxygen here, 3 times 16, that would be 48.00. We have 14 contributed from the nitrogen, and 22.99 contributed from the sodium. So then what we're going to do is we're going to simply add all those together. And this is merely calculator work right here. So we're going to add that minus 22.99. We're going to get 84.99. So that's 84.99 AMUs, atomic mass units. That is the mass of 1 sodium nitrate. Or, if we use it as molar mass, we would say 84.99 grams per mole of these ions. Let's go down and look at, we're going to look at calcium nitrate, which is this one down here in the lower right hand corner. And the reason I want to show you this one, calcium nitrate, is because we've got to do a little multiplication. Now, because we have 2 nitrate ions, and each nitrate ion contains 3 oxygen atoms, that means we have a total of 6 oxygen atoms this time. You multiply subscripts together. So we have 6 times the 16 each brings. We now have 2 nitrogen atoms. That subscript distributes to each subscript in the parentheses, just like you use the distributive property in math. And then we have 1 calcium, and each calcium is 40.08. So if we add these up, we get 96.00. We get 28.00 AMUs, and we get 40.08 for calcium. So again, I'm going to just add all these up. We'll just say 96 plus 28 plus 40.08, and we get 164 32.08 AMUs. You don't have to write all this out every time you calculate the molar mass of a compound. We can simply do it on our calculator, but sometimes when we get a lot of parentheses and a lot of subscripts, it is nice to write it out and see where we got those numbers from. So those are some examples of how to calculate the molar mass of an individual compound. The next thing we're going to be asked to do with this is to determine the percent composition of elements within that compound. So if you flip the page, on the back of that worksheet, you'll see one here where we are finding percent composition. And I'm confident that we all know how to calculate a percent of something. We all know how to calculate a part over a whole. And that's what we're doing in a percent composition problem. So if we look at the first one here for H2SO4, which is sulfuric acid, we're essentially being asked what percentage of this compound is made up of hydrogen, and what percentage is made up of sulfur, and what percentage is made up of oxygen. So our first step is to determine the total mass of H2SO4, which is essentially the molar mass. Then we can calculate the parts of each. So here's how we're going to work that. We have H2SO4. The first thing we need to do is add up the molar mass, just like we did a few moments ago. So we have 4 oxygens, each one's 16.00. We have 1 sulfur at 32.06. And we have 2 hydrogen. Each hydrogen's 1.01, so we're going to say, well, it's going to be 1.01. So for the oxygen, we have a total of 64.00 AMUs. For the sulfur, we have 32.06 AMUs, and for the hydrogen, we have 2.02. So adding those up, we should get a 98.8 AMUs. So that's our total molar mass for sulfuric acid. So what we're going to do individually now is calculate the percentage that each element occurs. So we're going to start with hydrogen. So for the percentage of hydrogen, we're going to take the total mass that hydrogen distributes within the molecule. So it has a total mass of 2.02 because there are 2 hydrogen atoms. We're going to divide that by the total, and we're going to multiply that number by 100 to put it into percent form. Then we're going to do the sulfur. Sulfur has a total mass of 32.06, and we're going to divide that by the molar mass of the compound times 100. And we're going to take the percentage of oxygen. That has a total mass in the formula of 64.00 divided by the total molar mass of the compound. Taking our calculator here, move that over just a little bit. You'll see for hydrogen, we're going to take 2.02, divide it by 98.08. What's that? Times 100. It's going to give us 2.06%. So 2.06% of this compound is contributed to hydrogen. Then we're going to do the sulfur, 32.06 divided by 98.08. What's that? Times 100. It's 32.69%. Oxygen, 64 divided by 8.08 times 100, whoops, times 100, 65. 0.25%. So these are our percentages of each element as they exist in the H2SO4 molecule. Hydrogen contributes 2.02 or 2.06% of the mass, sulfur is 32.69%, and oxygen is 65.25%. Now when you add up your percentages, they should come out very close to 100. May not be exactly 100 because of rounding. Look at that, that one does come out exactly to 100. So that's a good way to check your answers. When you get the percentages, add them all up and make sure they are at 100 or maybe within a tenth or so.